Hello, ladies and gentlemen. We are back today doing some AP Calculus. We're just going to take a little review here of some integration techniques, mostly with fractions. So again, here are all of our integral rules. We've got 20 of them or so that should be memorized. But for now, if you need to keep flipping back, here it is. It's in this presentation. It's actually in this presentation twice, but you've got it to flip back to if you need it. All right, so reviewing some integration techniques. So we've got three integrals here, and they all look quite similar. So we've got 4 over x squared plus 9. We've got the integral of 4x over x squared plus 9. And we've got the integral of 4x squared over x squared plus 9. So even though they look very, very similar, they are done in three completely different ways. So with the first one here, this one you should recognize, okay, we've got something squared plus something squared on the bottom and just a constant on top. This one is going to be arctan. All right, so we would say u equals x, du equals dx, and this would be our a equals 3, and this 4 out front would just move all the way out front. And then we go back and we take a look at what the arctan rule is. So let's see, where's arctan? Down here, number 19, right there. So we get a squared plus u squared. We have 1 over a, arctan of u over a plus c. So we've got the 4 out front times 1 over a, so 1 over 3 times the arctan of u, which in this case is just x, over a, which is 3, plus c. There is our answer for that guy. If we want to write this as 4/3 on top, or 4/3 in front, that's fine. We can do that. So that's the first one. The second one here, we should realize that, hey, the derivative of x squared is just a guy with an x. So this one we want to probably just do regular old substitution. So we'd set our whole bottom equal to u, and then our du would be 2x dx. So we could say, put a 2 here, and then put a 1/2 out front, and then the 4 can come out here with the 1/2. And like 4 times a half is just 2, so we would get 2 times the integral of du over u. So that'd be 2 times the natural log of the absolute value of u plus c. So we'd get 2 times the natural log of the absolute value, but we don't really need the absolute value because x squared plus 9 is positive. So we could just say the natural log of x squared plus 9 plus c like that. And if we want to, we can bring the 2 in as an exponent like that. So at this point, it's really just a matter of matching answers in the AP exam. So there's that guy. The third one, all right, the third one's the trickiest one. So when the degree on top and bottom is the same, or the degree on top is higher, we do long division. All right, so I don't know if I'm ever, well, we'll give it a shot. So we've got x squared plus 9 into 4x squared. We've got 0 x's and we've got 0 constants. I just want the placeholders here. So let's see, I've got to multiply this x by 4. So 4 times that is 4x squared. 4 times 9 is 36. And then we're going to subtract all this. So we're going to get a negative 36 here. So it looks like we're getting 4 plus, or I guess minus, plus negative 36. So minus 36 over x squared plus 9. All right, so that's what the inside becomes, dx. All right, so the 4 we just integrate. Integral of 4 is 4x. Easy enough. This guy, he's another arctan. All right, so we'd have minus, so we'll have 36, then 1/9, or 1/3, sorry, square root of 9, 3, arctan of x over 3 plus c. So we do 36 times 1/3 is 12, so we're going to have 4x minus 12 arctan of x over 3 plus c. So notice we get 3 very different answers. I guess these two are somewhat similar that they both have arctan, but again, lots of different things can happen when we have fractions and integrals. All right, so here's some more stuff. So let's see, we've got something squared minus x squared, like this is 2 squared minus x squared. That makes me think arcsine, but arcsine doesn't have an x on top. All right, so maybe we could split this. And then if just the x term, that could do substitution. And with the 3, we could have arcsine. All right, and this is a definite integral, so don't forget we are working with bounds here. So from 0 to 1 of x over the square root of 4 minus x squared dx plus the 3 times the integral, I'm just going to move the 3 out front, of 1 over the square root of 4 minus x squared dx, like that. Oh, and I left off my bounds there. 0 to 1. There we go. All right, so this first one looks like good old substitution because, again, the derivative of x squared is x, and we've got that on top. So we're going to say u equals 4 minus x squared. Du equals negative 2x dx. So we need a negative 2 here. We'll put a negative 1/2 out front to cancel it. So we're getting negative 1/2. I'm going to leave off the bounds because I've switched to a different variable. We're getting u to the negative 1/2 du. I'm just going to keep going here for now. So we're going to get negative 1/2 u to the positive 1/2 over 1/2. These 1/2s are going to cancel, but we're still going to have this negative sign. So we're going to have negative square root of u, which was 4 minus x squared. And again, this is from 0 to 1, so I can put my bounds back in. We'll evaluate that a little later. Let's go over and do the other side here. So now the other side, let's see, our a is 2. Our u is x, so du is dx, so we don't have to fuss with the du here. So it looks like we are getting 3, so plus 3. And then we've got arc sine, which doesn't have a 1 over a term, and it's x over 2. All right, and this is from 0 to 1. All right, so we've got both of these. Let's just go ahead and do each one. So if we plug in 1 here, we get negative square root of 4 minus 1 minus negative square root of 4 minus 0. All right, so we get negative square root of 3 plus 2. Right? These are going to cancel out. Square root of 4 is 2. So there we go. Our 2 minus the square root of 3. All right, for this one, we plug in 1. We get 3 arc sine of 1/2 minus 3 arc sine of 0. Arc sine of 0 is just 0. Arc sine of 1/2. This angle whose sine is 1/2. We're back in the first quadrant. 1, 2, square root of 3. So this must be pi over 6. So we get 3 times pi over 6, which is pi over 2. So we got this plus this. So we get this plus pi over 2, and there is our answer. Wow, a lot of stuff happening there, huh? All right, let's change colors and do the other one over here. I'll do the darker red. All right, so, we've never done anything with x to the 6th in here. But the thing that I notice is that this guy is a perfect square, right? This is 4 squared. And this guy we could write as x cubed squared. And then it is the difference of squares. So like our a would be 4, and our u would be x cubed, which is kind of weird. We never had like anything with an exponent here. But that's okay, we can do that. So then du would be 3x squared dx. We've got the dx, we've got the x squared, it just needs a 3. All right, so if is the constant minus the variable inside the square root, and they're both squared, that is arc sine, just like we had over here. So this is going to be 1/3, because of that 1/3, arc sine of, our u is x to the 3rd, and our a is 4. And that's how we get that. All right, that's that one. All right, so that is our just a quick review of doing some integrals with some fractions and what the different cases are and when to use which one. The next one will come back with integration by parts.